Good morning and welcome to today's webinar, Tracerco Radiation Monitors, a commitment to safety in the oil and gas industry, sponsored by Tracerco. I'm Chris Smith with Oil and Gas Journal. To begin, let me explain how you can participate in today's presentation. First of all, if you have any technical difficulties, please address them in the questions window and our technical experts will help you out. We recommend disabling any pop-up blocking software or extensions in your browser as they can cause issues with the webinar player. Additionally, we welcome your questions during today's event. We will answer as many questions as possible during the Q&A session that will follow the main presentation, but please feel free to send your questions in at any time. To do so, simply type your question into the Ask a Question window on the side of your screen and hit the submit button. Also, please be aware that today's session is being recorded and will be available on the Oil and Gas Journal website within the next week. You'll be notified by email when the archive is available. Now I'd like to introduce today's speakers. Nick Hutchinson is head of Tracerco Radiation Protection Advisors Department. Simon Lambert, Technology Manager for Tracerco, Dorsaf Sharif, Business Development Manager, and Sinem Stevenson, Radiation Monitors Business Unit Director for Tracerco Limited. Team, take it away.
Thanks, Chris. Thanks for the great introduction. I wanted to add a very briefly that between four of us here today, we have got a combined 68 years of experience in radiation, and that is covering everything from radiation protection compliance to handling sources, monitoring radiation, and delivering solutions that help keep people safe. In terms of why we are here today, we are here to talk about the why smarter radiation monitoring really matters. Because at the end of the day, it is all about keeping people safe. First off, safety isn't optional. Whether you are on a drilling rig, handling equipment, or working in a processing facility, radiation is a real risk. But with the right monitoring in place, we can manage that risk effectively, protecting both workers and the environment. Then there is the compliance piece. We all know it is necessary, but it shouldn't slow you down. The last thing anyone wants is for safety checks and reporting to become a bottleneck in operations. That's why our solutions are designed to be both accurate and efficient, giving you the data you need without disruption in your workflow. At Tracerco, we focus on making radiation monitoring smarter, not harder, so you can focus on getting the job done safely with the confidence. With that in mind, let's dive into how our technology supports you in the field. Please go ahead, Dorsaf.
We will start with the radiation monitoring in the oil and gas industry. Radiation has played a significant pivotal role in advancing in the oil and gas industry and its capabilities and its operational capabilities. It offers many production benefits, but also unique challenges. Some of the most important radiation-based applications that are integral to our industry come with a very high level of risk. For instance, let's talk about the industrial radiography, mobile gauging equipment, along with steel sources, for example, used in picking activities. These are very essential for ensuring pipeline integrity, for instance, and detection potential flaws, weaknesses. But however, they use sealed sources that pose a risk of very high dose rates, leading to accidental exposure to the primary beam or contact with any unshielded sources, really, which can result in massive injuries. We have another critical applications, for example, well logging activities that utilize this radiation to provide detailed information about the geological formation surrounding a borehole, for example. So the main benefit being that the collected data is crucial for making informed drilling decisions and optimizing resource extraction. Moreover, we have managing naturally occurring radioactive materials, NORM, as we say it, which is an ongoing challenge that requires careful monitoring to prevent environmental and health risks. So Simon will later on delve into the norm topic in more detail shortly. We also have the installed nucleic process measurements devices that are used in various operations to monitor and control processes. We also have the unsealed tracer studies and diagnostics that are employed to analyze fluid movements, for example, and so many other potential applications. So each of these applications underscore the importance of radiation in the oil and gas industry and highlights both its benefits and the need for stringent safety and compliance measures. Effective radiation exposure monitoring is very crucial in the oil and gas industry to ensure the safety and the health of workers who may be exposed to those ionizing radiations. So let's focus a bit on the key elements that make up this critical aspect of our operations. So we firstly start with the critical health safeguarding, which is paramount. Protecting workers from both acute and chronic health effects is very essential. So this involves implementing robust personnel dosimetry measures to monitor dose rates and also contamination levels. Tools and products such as those offered by Tracerco play a vital role in keeping personnel safe, providing real-time data that enhances their safety protocols, but also minimizes the risks. Secondly, we talk about compliance. So compliance is a key component of radiation safety. Adhering to exposure limits set by regulatory bodies is not only necessary for protecting health, but also for avoiding legal liabilities and financial penalties. Monitoring is integral to achieving radiological compliance, and a portfolio of hazardous area certified products ensures that operations remain within regulatory standards. Lastly, the use of fit-for-purpose products for monitoring is essential for maintaining that operational efficiency we talked about. So products that are specifically designed for the oil and gas industry are trusted to perform reliably even under harsh conditions. So these innovations ensure that monitoring equipment is both effective and resilient, supporting the industry's demanding environments. So this leads us to the importance of operational dosimetry in the environments and application we've discussed earlier. Dosimetry has evolved to become a crucial element in ensuring operations proceed with minimal risks. It is essential for creating a safer working environment, and it also provides the necessary data to work towards a risk-free setting as much as possible. As we explore the evolving role of personal dosimetry, it's vital to understand its practical aspects in safeguarding workers in our industry. So firstly, operational dosimetry, as we said, is crucial for worker safety, providing real-time monitoring of radiation exposure. This ensures immediate protection and awareness for workers in hazardous environments. Through the pads, through the personal electronic dosimeters, workers receive instant feedback, which is vital for enhancing safety and preventing incidents. Moreover, incident prevention is significantly bolstered by instant alarms and feedback mechanisms that help prevent overexposure incidents. So safeguarding workers' health in the best way possible. So this proactive approach is particularly critical in high-risk areas, such as we mentioned earlier, and where radiation exposure is a major concern. In addition to this, regulatory compliance, as we said, plays a key role in supporting adherence to safety regulations and industry standards. So it ensures that radiation levels remain within safe limits, and all the recommendations from authorities like the Health and Safety Executive, for example, they emphasize the necessity of using the personal electronic dosimeter alongside with the passive dosimeters that we have, especially in those types of environments. Compliance here not only protects health, but also prevents legal liabilities. Furthermore, enhanced risk management is achieved through dependable, accurate, and timely data on radiation exposure. This approach facilitates improved risk management practices, ensuring a safer working environment. And finally, data-driven decisions are enabled through comprehensive data collection and analysis, allowing for informed decision-making and continuous safety improvement. As we transition to the next session, we will explore how advanced dosimeter solutions effectively address these critical monitoring needs, enhancing safety and operational efficiency.
We'll explore how radiation monitoring ensures safety in log while drilling applications. The key points that we'll cover will be the reasons for using seal sources, the potential issues that can arise, and some of the tools and techniques for mitigating these risks and ensuring compliance. So, firstly, why are sources used in drilling operations? Well, sources are commonly used to evaluate the formation properties. They let operators see beneath the surface in real time and measure things like density and porosity whilst drilling, which helps improve operations and cut out any unnecessary activities and risk. But it also means that robust safety measures are needed to ensure responsible source management. Having an effective monitoring program is a must-have to stay compliant, which obviously requires reliable monitors that work well on site. And this is where the Tracerco products really shine and come into their own. So let's move on to discuss what type of incidents can occur in LWD and how our products can help to manage that. So drilling activities are tightly regulated and do involve responsible operators, so incidents are fairly rare. However, when they do occur, they can pose serious health, environment and operational risk, as well as compliance issues and potentially reputational damage too. Most incidents do tend to stem from either human error or equipment failure. Those that are deemed foreseeable by the IAEA include things such as mechanical damage, stuck sources, leaking sources, lost or dropped sources, and a few other less likely scenarios. However, operators need to consider all of these possibilities, in addition to their normal operational measures, and have emergency response plans in place, along with the suitable equipment to handle such incidents. So one of our devices that is commonly used to provide protection against equipment failure is the Tracerco Mud Monitor, which is used to detect any source integrity issues early before they escalate. At the well site, the radioactive sources are preloaded into the drilling tools before going downhole. These tools also have integrated detectors in them, which measure backscatter radiation and provide information while they're drilling. Once the tool is operational downhole, drilling mud is circulated in a closed loop to enable the drilling to happen. The source capsules are very tough indeed and made from double, if not triple, encapsulated stainless steel. However, in rare cases, they can still get damaged, which, if undetected, can lead to worker exposure and contamination of equipment. The Tracerco Radiation Mud Monitor, RMM, is used by oilfield service companies and operators to detect any unexpected radiation in the drilling mud resulting from a capsule failure, and it immediately raises the alarm. Naturally, the product is hazardous area certified, intrinsically safe for Zone 0, as most of the Tracerco products are. It can be easily integrated with well site systems using either industry standard 4 to 20 milliamp outputs, or serially using a WITS protocol, stands for Well Site Information Transfer Standard, which some systems use. Onto the package itself. So the monitor itself is a non-intrusive device and does not need to be in contact with the process. It attaches directly to the outside of the mud return line using a powerful magnet as shown in the image. As far as the cabling goes, there's a choice of industry standard connectors that can be chosen, making the installation and removal quick and easy with no need to deploy specialist skills such as electricians and the like. This can be particularly beneficial given that rigs are relocated fairly often. For integration, there are a choice of either a local display with an alarm sounder, standalone unit, or it can be integrated directly into the site DCS or drill control system. So moving on to the software elements. The software for the Mud Monitor is available for download, and it's a really handy tool that supports everything from calibration, device configuration, real-time visualization, and fault diagnosis. So to summarize that little section, I would say that the mud monitor is used to proactively monitor seal source integrity by detecting any unexpected radiation in the mud stream to ensure the safety of both your personnel and your equipment. So we're going to pause the slides now for just a few minutes and hand you over to Nick, our head of radiation protection, to delve into some of the real-world practicalities of radiation protection and for him to share some of his experiences and insights from working in the industry and being an RPA for many of the oil and gas operators for many years. So over to Nick.
Thanks, Simon. A fundamental principle of radiation protection, regardless of your location, is that doses must be kept as low as reasonably practicable. And here, regular and area and personal monitoring enables us to achieve this. Some of the practical considerations for the user would include: what are the user's expectations? What are we trying to measure? Are you simply wanting to detect or measure radiation fields? For example, are we looking to detect norm or measure dose rates? Advice should obviously be sought from your radiation protection advisor or your qualified expert on selection and use of monitors. Furthermore, it's vital that the user follows a suitable monitoring regime and that those using the monitor are trained. That is, they know what to monitor, how to use the monitor, and the importance of recording the results. And I emphasize that results must be recorded to demonstrate legislative compliance. In my experience, the biggest variable in monitoring is the user themselves. So training is essential in that respect. Preferably, any training should include practical sessions so that we can get hands-on with the instruments, and this will reinforce learning. And it also illustrates the importance of being aware of things like the instrument's response and its response time. Is it the correct monitor? Will it actually respond to the source of radiation that we're interested in? And also, how fast does the monitor respond? For general rules of thumb for monitor users, we should consider things like know the type and the energies of the range of radiation to be measured, use the monitor with the most appropriate response, ensure that the monitor is properly maintained and tested at regular intervals, and normally this is every 12 months. If the choice of monitor is not available, then we've got to be aware of any limitations, and we must maintain calibration records or certification as part of our radiation records, again, to ensure legislative compliance. Again, I emphasize the importance of recording the results, and with contamination monitors in particular, we may want to check the instrument's response prior to use using a low activity test source. In addition to area monitors, and as Dosaf has touched on earlier, electronic personal dosimeters, such as Tracerco's PEDs, are often used to complement passive dosimetry, which are worn legally by classified and Class A personnel. The upside of these PEDs is that they provide the user with immediate indication of the dose received through direct reading. Furthermore, they often include additional functionality which can prove extremely useful to the wearer. For example, they will have auditable and vibrational dose and dose rate alarms, the facility to store data. They will allow multiple wearers, whereas passive dosimeters don't. They are IS, or many of them are, and they can be used in off-body modes, which enables the device to be actually used as an area monitor, i.e. it can measure dose rates. So now I'll pass you back over to Dorsef, who will provide further insight into our range of area and personal monitoring devices.
You can go to the next, Sinem. All right, so we'll begin with our T202 dose rate survey monitor. So the intrinsically safe dose rate survey monitor is another one of our intrinsically safe products that are designed for use in flammable atmospheres. So it is extremely robust, very easy to use, and has been proven in use in thousands of onshore and offshore facilities worldwide. So many references for this guy. So it allows accurate and energy compensated dose rate measurements for many applications, from transport indexes to critical examination operations and source accountancy, both again on and offshore. Very easy to use, like we said, one button press turns it on quickly to display a dose rate that auto-scales its measurements. The displays use both a graphical analog bar chart and large digital readouts. And in addition to being able to set up alarms, it has a dose rate clicker function. So you can get actually a good sense of the reading without even looking at the screen. So one of the most useful functions of this monitor, according to our own RPA, is the peak reading, accessed by pressing the button on the top right-hand side of the monitor. So it is actually very good for when you cannot see the display. So for example, when you're monitoring at height or feeding into a vessel fitted with a nucleonic instrument to confirm source isolations, for example. And now moving on to the next slide. And I will introduce now our personal electronic dosimeters portfolio, which was crafted to enhance safety and efficiency in the oil and gas industry. So these dosimeters are 8X intrinsically safe certified. So they allow seamless use across various scenarios without specific paperwork, without cumbersome paperwork. So starting with real-time monitoring, the pads provide immediate dose feedback, thus ensuring instant awareness and response to radiation exposure. So this real-time data is crucial for maintaining safety in hazardous environments. Moreover, enhanced safety features include audible and vibrational alarms for dose and dose rate, along with data storage for later analysis, GPS logging to track exposure locations, and so on. These pads has been built to be rugged and reliable. They are weatherproof, shockproof, suitable for use without permits, without hot permits, making them ideal for challenging conditions, as we all have in this industry. In addition, they support recognized best practices like ALARA by offering active monitoring that complements the passive data, helping to prevent incidents through immediate feedback. So their flexibility and ease of use are noteworthy. These devices can be assigned to multiple users. They can be linked to specific tasks. They are used in both personal and off-body modes, thus enhancing operational efficiency. And moreover, they require no training because they're very easy to understand, which make them user-friendly. So these pads are supported by Dose Vision 2, our desktop software and cloud. So they meet the regulatory expectations we previously discussed, and as we said, recommended by authorities like the Health and Safety Executive. They're ideal for use alongside passive dosimetry in the high-risk scenarios Simon and I have mentioned. So let's explore a bit the features of our pads. So first of all, it stands out in the market due to its user-friendly design and advanced functionality. So our pad features an easy-to-read display with a graphical color-coded interface and embedded alarms, ensuring clear communication of radiation levels. So the users can easily access additional information via the carousel screens. So with the short button press, you get the cycle through the carousel screens quickly to view key information such as the home screen, the task recording, and the dose rate screen. The long button press will allow you to enter the menu to select specific items and configure settings and so on. Going back to the task feature allows for easy identification and summary of task-related dose data directly on the device. And also we have a discrete mode option for those who are interested that silences audible alarms and dims the screen, providing flexibilities in various environments. So these features combined with improved visuals and simple menus enhance fast learning and on-the-spot decision-making, ensuring operational efficiency and safety. So, introducing the DOSE Vision 2 companion software, which is a modern connected system that offers comprehensive features to enhance radiation safety management. So, it's accessible via web browser through the DV2 cloud, the DOSE Vision 2 cloud portal. It provides numerous benefits. So, first of all, the software highlights risks with intuitive dashboards tailored for individuals, for teams, and the entire organization as well. So it allows for efficient monitoring and management of radiation exposure across different levels. Now, the key features of the DOSE Vision software include the asset management, which allows you to keep track of all dosimeters and related equipment, ensuring everything is accounted for and functioning properly. The calibration tracking, so you can stay informed about calibration schedules, ensuring all devices maintain accurate and compliance. And also the last synchronizations information, for example, so you can easily monitor the latest data updated and the same synchronization activities, ensuring you have the most current information. So the DOSE Vision 2 companion software also provides robust capabilities for managing radiation doses, offering seamless data collection and detailed analysis. So let's start with the seamless collection, for example. So effortlessly of those data, ensuring accurate record maintenance. Dose trend navigation allows you to easily explore those trends over time, from years down to minutes, down to seconds, enabling precise monitoring and analysis. And additionally, drill down capabilities let you actually conduct detailed surveys and log data with precision, even down to the second, for thorough investigations. And finally, we can also generate detailed reports that support compliance and safety initiatives, ensuring comprehensive dose investigations. So with these many features, the DOSE Vision 2 equips you with the essential tools for effective radiation safety management. And finally, as we said, so the DOSE Vision 2 companion software, it enhances radiation safety management. So starting with geolocating dose tracking. So devices equipped with onboard GPS, such as the PET Black, provides a visual trace of location and radiation levels, allowing us for precise monitoring of exposure, hotspots, and so on. We also have the Bluetooth mobile app feature that enables seamless syncing of those data with the mobile app, providing real-time access to information and also facilitating remote management. Furthermore, we have user-defined alarm messaging allows for customization of alerts, instructing users on actions to take in specific alarm levels. That way, it ensures prompt and appropriate responses. So all these features combined with the ability to use devices as ambient off-body survey meters enhance safety and operational efficiency, offering a comprehensive approach to radiation management. So in conclusion, effective dosimetry is essential for ensuring the safety and health of workers in the oil and gas industry. With advanced tools like the PET2 and the DOSE Vision 2 software, we can deliver real-time monitoring, detailed analysis, and user-friendly interfaces that enhance operational efficiency and compliance with safety standards. So, as we continue to prioritize safety, our focus now shifts to radiation safety for naturally occurring radioactive material monitoring in oil and gas applications.
Simon, we can't hear you.
Whoops. So, norm. Naturally occurring radioactive materials occur in nature and feature quite heavily in oil and gas operations. Specifically in oil and gas, this involves the decay chain elements of thorium and uranium. And oil and gas extraction tends to concentrate these materials into what is termed T-norm, or technically enhanced norm. And it's this that can pose radiation risks to workers, particularly during handling and cleaning operations. It can also cause severe operational issues like clogged pipes and vessel buildup. For instance, as per the left-hand side bottom photograph, in oil production, we often see radium-based scales or sludges forming in pipes and vessels. And in gas production, lead-210 or polonium-210 deposits can accumulate, sometimes even without being visible to the naked eye, as shown in the right-hand side image. Understanding and managing these risks is crucial for ensuring safety of the workers and for preventing operational disruption. In oil and gas, as NORM contains alpha, beta, and gamma emissions, there are two key hazards to consider: external radiation and internal exposure. Inhalation and ingestion pose the most significant risks here, so preventing the intake of radioactive materials is the primary goal of any PPE used. It's clear that proper NORM management and containment are essential and achieved by following local rules and controlled area protocols, and these are usually being pre-prepared by an appointed RPA. A big part of all this means knowing where NORM is, controlling it from spreading, and handling it safely. As radiation is invisible, yeah, you've got it, thorough and regular monitoring is another crucial requirement here, including area in situ screening of equipment and of personnel exiting controlled areas too. Tracerco, of course, do provide monitoring equipment for all of this, including the NORM monitor, which I'll detail next. But worthy of a quick plug here is that Tracerco also provide expert RPA services, NORM sample analysis, and specialised RPS and NORM training, all delivered by NIC's radiation protection and radiochem teams. So before we dive into the equipment, let's jump back over to Nick to hear some practical takeaways about effective NORM management.
Thanks for the kind words, Simon. When it comes to work scopes involving NORM, we use contamination monitors as screening instruments. So they allow us to determine whether something should be considered, I should say, as contaminated or not. So how do we know if the material requires special consideration? Well, there's a process that we go through. First of all, we use our handheld contamination monitors to screen. Then if we are able to detect NORM and it's sustainable, then we would take representative samples. Those samples are then sent to a radiochemistry lab, such as the lab that Tracerco has and operates. And through gamma spectroscopy and alpha spectroscopy, we are able to generate radiochemical analysis results. And those results are then used to enable us to categorize the waste, so waste categorization. And this will ultimately dictate where the waste ends up. So what is the route of disposal? In addition to this, monitoring equipment is also vital from a radiation protection standpoint. It facilitates designation of areas, whether or not we should designate an area as a controlled or a supervised area. It helps ensure that contamination is not spread outside of a work area by personnel or any other items leaving the active area. And in some cases, as Simon mentioned earlier, for example, gas production, contamination may not be obvious. And this makes contamination monitoring even more important, as there may not be any indication that the item is actually contaminated. Although the contamination may be fixed in the first instance, we would still use containment as a means of controlling the hazard. The work with NORM is fairly easy to manage from a risk perspective. The risk to personnel is mitigated through undertaking radiation risk assessments, working in accordance with your radiation procedures or your local rules, and wearing suitable PPE, which would probably include RPE also, depending on the levels of NORM encountered. And also fundamental is ensuring that workers are suitably trained. So I'll hand you back to Simon now, who will be able to provide you with further insight into Tracerco's range of contamination monitors.
Microphone back on. Thanks, Nick. Okay, next I do want to dive into details of the norm monitor, but first let's discover what having an intrinsically safe monitor really means to us. So for me, it means you can easily and rapidly deploy the equipment and make measurements pretty much anywhere in any norm scenario without fuss, enhancing safety and reducing liability. It enables efficient on-site screening that Nick spoke of, saving time and money. By identifying norm suspect materials, you can optimize the number of samples sent to the lab for analysis. Importantly, it is Zone Zero certified, intrinsically safe, so guarantees the highest level of safety and peace of mind, for both operators and users. And with its international approvals, such as IECX, and we also have CSA ATEX in metro approvals, it enhances operational efficiency for norm management across different regions, making it the ideal tool for customers that operate globally. It's also worth noting that in oil and gas, having certified equipment is often a requirement in order to comply with the safety regulations. And obviously, this is due to the significant risks and severity and consequences that could happen for an explosion. So, taking a closer look at the norm monitor kit itself, we see that it comprises a handset with the choice of 2 pluggable probes for alpha, beta, and gamma detection. It's IP67 rated and designed for durability and ease of use, even in challenging field conditions that we see. And there's features like a simple traffic light process to average readings automatically over time, activated by a dedicated button, which make it incredibly easy to operate. The output displayed largely depends on the probe connected. You can view counts per second, the dose rate, or a conversion to becquerels per square centimeter using a library of pre-configured isotopes. You can even customize this library for your own specific needs or isotopes. The SINT probe in the middle is highly sensitive to gamma radiation and ideal for screening and detecting radium scales through vessel walls or pipes without breaking containment. The probe design allows for a 360-degree radiation collection and is ideal for insertion into pipes or into tubulars. The second probe, the GM pancake detector there on the right-hand side, measures surface contamination levels and detects low levels of alpha and beta contamination when you have more direct access or once you've broken containment. This is very popular in gas fields due to its ability to detect lead-210 deposits. It has a detachable rotating head for ergonomic positioning, which falls back into itself for protection when not in use. And both of these probes are smart, or they hold their own calibration data and can readily be plugged into any other handset and offer the flexibility to cater for different norm scenarios. So to recap, in oil and gas in particular, the potential for flammable atmosphere often necessitates the use of hazardous areas certified equipment. The norm solutions we present here today were specifically developed to monitor norm in these types of environments, avoiding additional permits and safety or complex safety protocols, meaning that norm screening can be carried out in situ safely. The norm monitor is proven, reliable instrument, shown to provide lasting performance. And being a Tracerco product, it's not only tough, but also extremely easy to pick up and use. It has audible alarms. These can be set at absolute values or factors. For instance, 2 times background. And background can be assessed locally by the press of the button at the top right-hand side of the product. It takes a minute and it'll gather your local background data. The kit comes in a tough, high-quality transit case with options available for belt holster carrying solutions too. So to sum up, this monitor delivers a winning combination of safety, simplicity, reliability, and compliance, which add up to making it the perfect tool for norm monitoring in oil and gas. So I'll hand you over to Sinem just to close us out.
Thank you. Thanks, Simon. Right, so I think we really come to the end of it. But before we move on to your questions, I just want to take a moment to highlight the range of Tracerco products and services designed specifically for the oil and gas industry. So as you all know now, we provide certified radiation monitoring products that meet the highest industry standards, ensuring reliability in the field. Our collaboration services help maintain accuracy and compliance so you can trust your readings when they matter most. For those working in hazardous areas, we offer hazardous area equipment checks, ensuring that your monitoring solutions are fit for use in challenging environments. And when it comes to the service and support, our expert team is on hand to help you with your equipment running smoothly. If you need flexibility, we do also offer equipment rentals alongside expert radiochemical analysis to assess contamination risks. And also our RPA support, RPS training, and user training ensure you have the knowledge and compliance guidance to work safely. So really, it is. I think it's fair to say that at Tracerco, we don't just provide products; we provide a complete solution that help you maintain safety, compliance, and operational efficiency in the oil and gas industry. I also want to add another little note there. At Tracerco, safety isn't just a priority. It really is at the core of everything we do. Right now, as we speak, hundreds of our engineers are out in the oil fields, climbing towers, installing fixed instrumentation in refineries all around the world. So we do understand the challenges of the radiation protection in oil and gas firsthand. And that's why we have designed the best radiation monitoring solutions to give you both, well, to you and to us, the confidence to work safely in these environments. So with that, we would love to hear from you. So looking forward to picking up some questions posted in the chat. Thank you.
Great. Thank you all. A few of you in the audience have already submitted questions, so we're going to jump right in. If you'd like to submit a question, type it into the question window on the side of your screen and hit the submit button. And let's see the questions. All right. Here's a good one to start with. As Nick mentioned, is the intention to detect norm or measure dose rate? In some countries, such as Brazil, we often see dose rate measurements being used as a method to detect norm instead of CPS readings with instruments like the T407. What are the main limitations of using it for detection, and why is CPS measurement the more appropriate approach?
Very good question. So you're right, there are parts of the world that use dose rates to designate areas. Generally, we have two types of areas. We have controlled and supervised areas, controlled areas being the riskier of the two. And in places like Brazil and other parts of North America, they will designate controlled and supervised areas on the basis of dose rates. In the UK and in a lot of European countries, we tend to designate controlled and supervised areas on the risk of spreading significant contamination. And in doing so, dose rates aren't so much an issue for us to consider. It's more about, is there the potential to get this material inside the body through ingestion or inhalation? We view that as the biggest hazard, certainly in the UK. I'm not to say that dose rates can't be an issue, and certainly in certain parts of the world they are. But with gas production, often what we find is you may have significant contamination, but dose rates can be extremely low. So in that respect, designating controlled and supervised areas on the basis of spreading contamination outside of a work area into a clean area, we prioritize that over dose rates. So I'm not saying there's a right and a wrong way to do it. I'm just saying that different parts of the world have a different basis, a different criteria for designation of areas.
Sure.
Hopefully that answers the question.
Yeah, thanks for that. And relatedly, regarding a daily dose to workers, if the daily dose is, let's say, 5 microsievert, can I make it to 10 in one day and then give the worker a day off to compensate? What is the limit for this?
Well, as radiation workers, we will have dose limits that we need to work to. The aim of radiation protection, as I mentioned earlier, is that we keep doses as low as reasonably practicable or as low as reasonably achievable. So it's not about, you know, reducing or minimizing a dose one day so that we can have another day off. It's about keeping those doses as low as we possibly can every single day. That's our priority, and that's the basis of radiation protection, keeping doses as low as reasonably practicable, working within dose limits. We may employ dose constraints. We will have dose investigation levels that we don't want to exceed, but our priority is to keep doses as low as reasonably achievable.
It stands to reason. Here's another. One of the audience wishes to know if radium-226 and others can be detected by your equipment, and what conditions are best suited for the handheld tool and other add-ons to use.
Would you like? I'll answer this again, and I'll let anyone chirp in if need be. But yes, our monitors can detect radium-226. They allow us to measure counts per second, but as Simon suggested, they will also allow us to measure becquerels per centimeter squared, which has limited benefits, to be perfectly honest, because, you know, the scale or the sand itself can provide self-shielding. What other conditions best suited for handheld with the add-ons? So the GM, you're not going to miss anything. It detects alpha, beta, and gamma. The scintillation probe is ideal for measuring dose rates and designating areas on the basis of dose rates, which is important in certain parts of the world, as I spoke about earlier. And also the scintillation monitor is extremely useful for giving us a heads up. It allows us to do external surveys of process equipment so that we can potentially detect norm, the presence of norm, without breaking containment.
All right.
So in short, yes, the monitor will detect radium-226.
Excellent. One of the audience is based in Bulgaria, and they would like to know if they can buy Tracerco monitors there.
Yeah,
Okay.
you take this. Sorry, I jumped in.
But please go on, Simon.
No, I mean, Bulgaria, that probably falls under Dorsaf's territory, so you could give Dorsaf a call and she'll, she can help. Or alternatively, we do have e-commerce site now, so you can go on there, ask a question, order a product. So you have a few routes.
Just to add a little bit on that. So our HQ is based in the UK, but we have additional 5 different bases around the world. That includes Asia, US, different parts of Europe. We do ship everywhere within Europe from our UK base. So that wouldn't be, you wouldn't really necessarily need to have a local contact. And we do also have an e-commerce system that, again, we service customers globally via this e-commerce system to make it even slicker and easier for customers for their journey with Tracerco. Please, as Simon mentioned, Dorsaf will be very happy to receive your inquiry and response as soon as she can.
Excellent. And getting back to the technology with this one, can a detector be ruined if exposed to radiation above the limit indicated? Let's say the limit is from 1 to 10 MSV and I expose it to 12.
Yeah, you can overrange the products. We regularly do this as part of a test. So we overrange them, something like 10 times overrange where we possibly can. But they are type tested to well above the range. So yes, I mean, that's something as well. There's in some scintillation detectors that you find, once they are overranged, they kind of become blinded, and it takes them a long time to come back down, so to speak. But ours do not do that, and partially because we have the design for IS means that we've got to make them operate very low current. So that kind of tends to be self-limiting. So we do find that even if we overexpose our scintillation counters, that they keep on working just as they were, in the normal range. They come back down very quickly.
Okay.
I think the important point to emphasize there is that when the detectors become saturated, they won't collapse. So it won't be as if suddenly you're not getting any readings, which suggests you're not stood in a dose rate field. They will maintain an alarm. They'll maintain to show that the dose rate is over range, it's off scale, but the detectors won't actually collapse. They won't be ruined, in short.
Yeah.
All right. Excellent. Who can calibrate Tracerco monitors?
Well, technically, any calibration house can calibrate the monitors, but obviously we have 5 OEM centers around the world, in Tracerco, in the US, Europe, the UK, Australia, Malaysia. So we have a spread of them. When we say calibrate, when we talk about IS, there's calibration and there's also sort of annual hazardous area inspection. So what we've got to make sure of is that whoever's maintaining the products, calibrating the products on that annual basis, does actually have the expertise to do the hazardous area inspections, the annual checks. So that's just one thing to note.
Great. And here's a product ease of use question. Will you consider making a soft shell bag with 3 internal pockets to carry the Tracerco norm unit around in the plant, as an alternative to the current design, which is around 6 kilos, including the box?
Okay. We can take a look at that. That's very interesting feedback. We can certainly look at that. We do work with external companies on specialists, if you like, on carry solutions. So that's certainly something that we can discuss.
Yeah, I think that's a subject that we would probably follow up after the webinar. That's a very interesting proposal.
Equino, yeah.
All right. Somebody would like to know, how can I care for my monitor? Do you offer a warranty?
Yes, we do offer warranty. So there is the manufacturer's 12-month warranty. However, we obviously more often see the companies wanting to buy extended warranties because they just don't want to worry about their product. So we have options to provide extended warranties if that is what is required by the customer as well. So that we are quite flexible in terms of our warranties. But I think with that, I need to mention that and I'm not really serving a good purpose here, but I think in the industry, we are very, very well known on how robust our products are, and they really hardly fail. If anything, you'll see the same product with the same customer base for over 10, 15 years. But yeah, if anyone is interested in an extended warranty above the manufacturer's 12 months, we also do accommodate those. Yeah.
Excellent. Another technical question here. The T407 manuals state that its scintillation probe dose rate output is designed for norm screening per North American regulations, and that general dose rate surveys are not recommended. It also notes RA226 measurements show 30% lower rates than CS137. How does this impact dose rate measurements with SA50 and T407, especially in countries where dose rate is used for norm screening on external norm surveys?
I'll answer that one if you like. So that, as the person who asked the question suggested, these instruments are used for screening. So they don't necessarily tell us what the actual dose rate is, but they give us an indication of the dose rate. In addition to a contamination monitor, what we would probably suggest you use is a dose rate monitor, such as the Tracerco T202. Saying that, the accuracy of these monitors is good enough for designation of areas. So it's something that we can rely on, and it enables us to do that using one monitor as opposed to using two separate monitors. But yes, if you want to measure dose rates, then we would recommend using a dose rate monitor, such as the T202.
Okay. And one more here. Can your monitor and equipment get to us in Nigeria? I noticed that you didn't mention Africa.
Absolutely. It can definitely get to Nigeria, to Africa. Absolutely.
Yeah,
Right.
we can forward details, but we do have representation in Africa.
Yeah, we have done quite a bit of work in Africa over the years. We've worked in Nigeria, we've worked in Cote d'Ivoire, we've worked in Ghana and Angola. So yeah, we do quite a bit of work in Africa.
Excellent. Does Tracerco offer training courses specifically focused on norm monitoring and mitigation methods? Is there any specialized norm expert training available?
Yes, we certainly do. We run a lot of these training courses. And as I mentioned in my slot, when it came to norm, what we tend to do is we incorporate practical sessions, because there's nothing like getting hands-on with the instruments themselves, particularly the contamination monitor. We need to be sure enough that we are getting close enough to a surface so that we can actually detect the alphas and the betas, as well as the gammas, which obviously travel further. So yes, we do regularly. And what we'd like to do is incorporate practical sessions within our training sessions, just to reinforce any learning.
Okay. Well, we've reached or are approaching the top of the hour, and for anybody out there that has questions that we didn't have time to answer, we'll be getting back to you via email. And unless any of the panelists have some closing remarks they want to make, I'll wrap up today's presentation. Fair enough. On behalf of Oil and Gas Journal, I'd like to thank Tracerco for sponsoring today's event. And of course, all of you for joining, and have a great rest of the day.
Thank you.
Thank you.
Thank you.